The first step in our journey here in understanding and analyzing data is going to be to summarize some categorical variables. These are just variables that we have different levels of, as we mentioned, and we want to see how we can summarize these effectively. So as we mentioned, data can be organized in a number of different ways. Tables and graphs can give us an idea of the layout of what it looks like. Tables are tabular information, rows and columns that will provide an overview, and graphs will give us some representation of data such as pie charts and line charts. The frequency distribution will count the number of occurrences of each level or class of categorical data. And I use the term level and class, and they are interchangeable because some books will refer to them as classes, some will refer to them as level. I will generally refer to them as level, but I will interchange them just to help you along. So let's take a sample data set that contains the colors of buttons, red, green, and blue. The color column would then contain 3 levels of color, red, green, and blue. And we have a data set here. Here's the button owner. John has a red button, Jimmy has a blue button, Ethan has a green button, and so forth. The frequency distribution is a count of the number of occurrences of each level. So in the previous example, each level of color, we had 3 of them, count the number of occurrences to create the frequency distribution. So we count there are 2 reds, 2 blues, and 3 greens. Note that the levels do not need to be in alphabetical order. However, some statistical packages such as R will automatically do that for you. The relative frequency and percent frequency are a little bit different. The relative frequency of a categorical level is simply the proportion of the count of a particular level over the total amount of data. So for example, we count the number of blue items over the total number of all items that we have. And so we can compute the relative frequency for each level and put it in a table. So here we have the total number of items is 7. We'll use the letter N here in italics to signify the entire number of items in a data set. So in this example, N is equal to 7, and that is a common standard. So the sum of the relative frequency will always add up to 1 because everything is going to be a percentage. You'll notice here that these are percentages. So the blue, we had 2. We're going to take the count divided by N, so 2 divided by 7 is 0.286. In the next one, we have 3. 3 divided by 7, which is 0.429. And in the next one, we have red, which is 2. 2 divided by 7, again, that's 0.286. So the relative frequency for blue is 0.286 or 28.6%. In green, it's 0.429 or 42.9%. And the red also is 0.286 or 28.6%. Now, if you do this thing in Excel, you might get a little bit off because of some rounding. If you did this way, you'd see that it would turn out to be 1.001 due to rounding of the 3rd digit. But if you do an accurate frequency, you can easily see that if you added up all those counts, 2, 3, 2, you would get 7. You divide by 7, and you would get basically 1.00. So you can always round to that 1. The percent frequency, which I've kind of already done, is a more human understandable value to convey the relative frequency. The percent frequency is just calculated by multiplying the relative frequency by 100, which I had already done. We had a relative frequency of 0.286, just multiply it by 100, and you get 28.6%. In the case of green, 0.429, you have 42.9%. In the case of 0.286, again for red, it would be 28.6%. You could just move the decimal place to the right 2 places and get the answer.